These values of T1 and T2 are obtained by using discriminant formula for solving quadratic equation. From these values of T1 and T2, we find T1 plus T2 is equal to, if we will add these two terms will get cancelled, we will get 4u sin theta upon 2g. 4u sin theta upon 2g implies 2u sin theta upon g is equal to t. It means sum of these two instants, sum of these two time intervals T1 and T2 will give us the time of flight. So equal to time of flight. Also to find the difference of these two intervals, yani T2 minus T1, we will subtract T1 from T2. If we will subtract, we will get under root 4u square sin square theta minus 8gh upon g upon g, because 2 will get cancelled by the twice of this term. So it will give the time interval taken by the projectile from this point, say A, to this point B. So it means to cross two positions of same height h, the time interval taken by the projectile will be this one. To cross two positions of, or directly we can write time interval to cross two positions of same height h. So it will give us the time interval for crossing two positions of same height h. Sometimes for solving a few questions we require another form of equation of trajectory. The equation of trajectory which we had obtained was y is equal to x tan theta minus half g x square upon u square cos square theta. This equation of trajectory can be changed to another form, and that another form is by taking x tan theta common. It means multiplying sin theta upon sin theta in numerator and denominator. In the second term, we'll get x tan theta as common and 1 minus gx upon 2 u square cos theta into sin theta. U square sin 2 sin theta cos theta upon g. It will give you the range of projectile r. So it means y can be written as x tan theta into 1 minus x upon r. It is another form of equation of trajectory which will be used in solving several questions. One more thing, if the angle theta is not given from the horizontal, it is not given from the horizontal, it is given from vertical. So if angle theta is given from vertical, then these components u sin theta will change to u cos theta and u cos theta will change to u sin theta. Either we will change these two components, interchange these two components and then proceed in the same manner to find all these equations, or we can directly put 90 minus theta in place of theta, because if theta will be given from vertical, then this angle will become 90 minus theta. So if angle theta is given from vertical, then we can replace theta in all these equations by 90 minus theta. Sometimes in few questions the plane is not taken horizontal, plane is taken as inclined. So for projectile motion on inclined plane, for dealing projectile motion on inclined plane, we have two possibilities. If here is the projectile thrown at angle theta with the inclined plane with the speed u, then say projectile hits the plane at this point, it is the starting point, this is the point P where the projectile hits the plane. Then here these two motions can be dealt in two ways. One, by taking components perpendicular to incline and components of velocity or components of motion along the incline and perpendicular to incline. If we are taking the component of velocity perpendicular to incline, it will become u sin theta, and here it will become u cos theta. All the equations of uniformly accelerated motion will be used for the motion along the incline as well as motion perpendicular to the incline. Both the motions are uniformly accelerated because if we are considering g, so g is acting vertically downward. If it is the direction of g, then component of g perpendicular to incline will be g cos phi, and along the incline it will be g sin phi. So it means again for considering the motion, for solving the questions which include motion on an inclined plane, projectile motion on inclined plane, we will take the component of g, one along the incline, g sin phi. It means motion along the incline will be a retarded motion with retardation g sin phi, while motion perpendicular to incline will again be a retarded motion with retardation g cos phi. As phi is constant, these two accelerations will be constant. Hence, we will deal these two motions with the help of equations of uniformly accelerated motion. One more way is there for dealing with this type of problems, and that is instead of taking components of velocity perpendicular to incline and along the incline, we can consider the motion along horizon as well as along vertical. Say here it is inclined plane with inclination phi, body is projected at an angle theta with the inclined plane, then we will be having two components of its velocity. Say this point is the point where projectile hits the plane, then component of this point can be taken as x, y. X will be this horizontal distance, while y will be this vertical distance. Now the vertical motion will be a retarded motion. Vertical motion will be a retarded motion with retardation g, and here this whole angle will be theta plus phi. So this component will become, uy will become u sin theta plus phi, while horizontal component will become u cos theta plus phi. And now the vertical motion will be the uniformly accelerated motion with acceleration g, while the horizontal motion will be the uniform motion with formula velocity is equal to displacement upon time. So it was all about the projectile motion and solving questions related to projectile motion.